I know. I might say if I don't get it set up. Okay.
7, 8.
There we go.
10.
It says Evelyn is designing a pattern for a quilt using this polygon. Evelyn transforms the shape so that the image of point E is at 2, 0. So moving this point E to 2, 0, so this would be E prime right here. And then the image of R is at 6, negative 7. So moving point R to 6, negative 7, R prime. Okay, it wants to know which transformation could Evelyn have used to show that this polygon and its image are congruent. Well, we're going to go through each answer choice and see which one would cause this transformation. The first one says that the shape was reflected over this line, y equals x plus 2. Graphing that line, we'd put the y-intercept is 2, and then the slope is 1, so up 1 over 1. It creates this line. Okay, there's the line. We have to see if this is reflected over that line, and no, because if it was reflected over it, E would be over here, the same distance from the line. So A is not correct. Then for the next answer choice, our shape is translated to the right 7 units and down 4 units. So if we were to move this point to the right 7 units and down 4, it does land at E prime. And if we do the same translation from R over 7 down 4, it lands at R prime. So this is definitely a possibility. We need to make sure, though, with the other answer choices. It says the shape is rotated 135 degree clockwise about point Q. Point Q is right here. If it was rotated 135 degrees, then we should be able to draw like a segment from the center of rotation to E and to E prime and get a 135 degree angle. That angle looks much bigger than 135, so this is not the correct answer. And this one here, the shape is rotated 90 degrees clockwise about point negative 3, 1. So finding negative 3, 1 is right here. If it's rotated from that point, the line from E to the center to E prime should be 90 degrees. That does look pretty close to 90 degrees. Let me see if there's a 90 degree angle from the center to R and R prime. And there's definitely not a 90 degree angle there, so it's not that rotation. So the answer is B. Okay, and the next one, we're going up to the top. Okay, here is a proof. It says that HQ is parallel to TX. And we're actually just going to look at what it's asking for, because sometimes we don't even have to look at the whole proof. It says complete the proof by filling in blank 3 and 6. Okay, so without looking at the entire thing, because sometimes proofs can be confusing, we can just look at the statement for that reason. Here it's saying that angle FNH, this angle here, is equal to RWV, this angle here. Looking at the relationship between those angles, they're corresponding. So for reason 3, I'm looking for the corresponding angles reason. Here it is. If two parallel lines are cut by transversal, the corresponding angles are congruent, and then you can just like drag and drop that there. And then next one, we have to fill in blank number 6. Let's look at these angles and see what their relationship is. NPR, this angle right here, and RVW. Oh, I should have used a different. This color's too close. Okay, these two angles are alternate interior angles, so I'm looking for that here, alternate interior, and then drag and drop this into the block.
I actually did that and got it right, and I hate those things.
Cool. Awesome. Awesome. Okay, next problem, number 12. It says that we have a trapezoid here. It's inscribed inside a circle. Something to write down, just take a note of, is opposite angles in an inscribed quadrilateral are supplementary. Okay, so that means that like angle B and angle D would be supplementary. They would add to 180 degrees. Also A and C would add to 180 degrees. So as I look at this is what I'm looking for. This angle right here, angle ABC, is equal to 180 degrees minus this angle. So 180 minus this angle, which would be ADC. And that's it. And the next one, do you have it written down? Another proof, but I promise there's a shortcut for this one too. It says Catherine uses triangle ABC where DE is parallel to AC to prove that a line parallel to one side of a triangle divides the other two sides proportionally. There's a lot of blanks in this proof, but we need to look at what it's actually looking for. It says which statement completes step 8. That is literally the last step here. That's going to be our proof statement. So they told us that we have to prove that the parallel lines divides this proportionally. So this is proportional to this, and this here is proportional to this. So looking at the answer choices, it's not going to be subtraction. It's not going to be equal to. It's going to be one of these proportions. So for the first one, it's saying BA is proportional to this over here. While that may be true, that's not what they asked us to prove. So this is not our correct answer. And then the last one, DA is proportional to BD, which is what we were looking for. And CE is proportional to BB or BE, however they wrote it. And that's our answer. Okay, next page. Okay, we have two circles here. We need to prove that they are similar. You can prove that shapes are similar by dilating it to be the same size and moving it onto the shape so it all lines up. It says Logan performs 2 transformations on circle A to show that circle A is similar to circle B. He first dilates the circle. That's important that they're dilating first, and then transfers it onto the new circle. Okay, so we have to dilate the circle by a scale factor. Circle A, the radius equals, and we can look at it, the distance from the center to the outside is 1 unit. And for circle B, the distance from the center to the outside is 3 units. Okay, so they're multiplying by 3, so the scale factor is 3. When you have a dilation from the center, and it does tell us that the dilation from the center, with the center of dilation at the origin, you can multiply the x and the y by 3. So this would be 3x and 3y. Then we need to translate it into the same position as circle B. So to translate it, we're going to move it over to the right 1, so that would be x plus 1, and we'll move it down 2, so that's y minus 2. So we dilated it so that it's the same size, and then translated it into the position of circle B. Next, this one should be familiar to you. All they're saying is that this rectangle is rotated around this line. What shape does it make? It is... Do you know the answer? I hope. It's A. Okay, we're going to move up to the top right now. The equation for line A is shown. It says line A and B are perpendicular, and the point -2, 1 lies on line B. Write an equation for line B. When 2 lines are perpendicular, the slopes are negative reciprocals. So for our equation of a line for a line perpendicular to this one, our slope will look like this. Y equals positive 3/2 x plus b. So this gets flipped to be 3/2, and it's negative reciprocal, so opposite sign would be a positive 3/2. Now, to complete the equation, we need to find out what our y-intercept is, and we can use these points to do that. This is x and y. We'll plug this into the equation and then solve for the y-intercept. So y is at 1 equals 3/2 -2 plus b. So we're going to multiply these two numbers. I don't know if this will be on the calculator or non-calculator portion of the test, so we'll just do it by hand. -6/2 is -3. So we get 1 equals -3 plus b. And then solve for b. And there's your equation of the line. Y equals 3/2 x plus 4. As far as typing this in, you should be okay because Khan Academy has a similar format. You could either click the Y button or you could type it in. It's also the fraction symbol here. If you need to use that to set up the fraction, they have a button for that. Okay, and the one right below it is another transformation question. I remember from a few years ago there are a lot of transformation questions on the EOC, and that's why I assigned those for Khan Academy this week. This one is in a different format than you've seen, but it's the same concept. Nicole, Jeremy, and Francis each perform a transformation on triangle RST. Each recorded his or her transformation, and the location of S prime in the table. Point S of triangle RST is located at 5, -7. So the original is at 5, -7. So looking at this transformation, it's actually translation first. The original would be at 5, -7. And we have to figure out what they're adding to get to S prime. So 5 plus what equals -6? Well, plus -11. That would be your A. And then -7 plus what equals 12? It is 19. Next one, again, the original point stays the same for all of these. So 5, -7.
-7 plus 12 is 19.
So to get from -7 to 12, -7 plus what equals 12? Yeah.
Now you're doing -7 plus 12.
Yeah. So your x and y is right here. So this would be 5 plus what equals -6. And then -7 plus what equals 12. Yeah, I know. Some of these you might want to practice on your own just so they're familiar if you see them.
I don't know practicing.
I might make you.
Oh,
I need more printing money.
yeah.
I know. 5 times what equals -15, it would be -3. And then -7 times what equals 21 would be -3 again. And the last one is a little bit more complicated. Not too bad though. We're going to set these equal to the answer and then solve for A. So 5, -7 is our x and y. So it'd be 5a plus 1 equals -4. And -7y minus 6 equals 8. And then solve for A and B. Okay, and next, this last problem, and yes, this is just one problem. It's problem 11, but it has part A, part B, and part C, and they're all part of the same thing. It shows a diagram. It says to select all assumptions that must be made about triangle PRQ and TSR to show angle-angle similarity for the triangles. When you're looking at triangles like this that are similar, these lines are actually parallel. And that'll help you figure out which angles are the same. So parallel lines with a transversal would make alternate interior angles congruent. So this is equal to this angle. Then this is equal to this angle because alternate interior angles are congruent. And then vertical angles are the same as well. Now we have to figure out which ones show angle-angle similarity. Well, proportionality may be there, but it doesn't have anything to do with the angles. So just cross these two out. Then is angle S equal to angle Q? Yes, they are equal. Is S equal to P? Nope. Is T equal to Q? No. And angle SRT is equal to QRP? Yes, that is correct. By the way, there is like a cross out function on FSA, which you may already know, but you can cross stuff out. Part B, which transformation should be applied to show similarity? Why is this so blurry? Ish. I don't know.
16 minutes, 2 more minutes.
Okay, I need to stay focused. When transformation should be applied to show similarity. If you rotate about point R and then translate, rotating might work, but when you translate, you're not putting it on top of itself. To show similarity, you want the shapes to be on top of each other and dilate to match. Reflection about point R followed by translation. If you reflected it, the corresponding angles wouldn't match, and then translating would put it in a new spot, so no. Rotation about point R, okay, if you rotated it, you would get it on top of itself, and then you could dilate. Yes, this is correct. And the next one was reflection over point P. I don't even know what they're talking about there. Nope. Next. Okay, last part. Applying. This one's D. The definition of similarity in terms of similarity transformations. We used the definition of similarity in terms of similarity transformations to prove that triangle PRQ is similar to triangle, and when you name the triangle, you have to make sure the corresponding parts are matching. So TRS. And when I named it, I made sure they did pink, blue, orange. I did pink, blue, orange as well. Not that you'll have colors on the FSA, but yeah. Thereby showing that two congruent angles are sufficient to prove similarity in two triangles.
18 minutes.
And we done now. Good job, y'all.